So the computer simply comes across the matrix cell by cell and sorts this image according to the density of each cell, or the pixel value contained, rather than the location of that cell. So all of the black pixels will be placed in a particular computer file represented by this bucket. As the computer comes across, white pixels will be placed in this file. Light gray pixels will be placed in this file, and all of the medium gray pixels will be placed in this file. So these buckets each represent separate computer files. So this kernel has a simple function of adding the pixel values of all 8 pixels surrounding the dead pixel, and then averaging those numbers. So when the computer brings the kernel centered over the dead pixel, it will sum these 8 surrounding pixels, 2 plus 3 plus 4, 3, 6, 2, 3, and 6, and then average those numbers by dividing by 8 and obtaining a new pixel value of 3.6, which will be artificially inserted into this pixel in the image. So that's an example of how kernels can correct for noise. An example of a global operation is translation of the image, or flipping the image left to right, in which case the computer simply reassigns whatever value is contained in A7 to cell K7, whatever value is in B7 to J7, C7 to I7, and so on, progressively towards the center of the image. Our imaginary machine might start out by scanning across the field of view at low frequencies. At a frequency of 6 hertz, or 6 prongs per meter, we find that these small objects remain undetected. They are invisible at this frequency. But as our machine continues to scan across, it is able to detect one object whose wavelength precisely matches this frequency. What our machine might do is store that information as a pulse in a computer file with a long wavelength. Our imaginary machine scans across the field of view at middle frequencies. It scans across again at high frequencies. When we reach a frequency of 12 hertz, we're able to detect one object here whose small size matches the short waves associated with this high frequency. And as it scans across further, it's also able to detect a second object over here of the same size, even though this object superimposes or overlaps a larger object in the image.